Welcome to True Projects. In this video, we are going to explain about a project titled Analysis and Detection of Autism Spectrum Disorder using the machine learning techniques. The main focus of this project revolves around autism spectrum disorder, a neurodevelopmental condition that affects the brain functioning. While ASD can become an apparent at any point in life, it is commonly diagnosed during the childhood with a higher likelihood of identification between the ages of 2 and 3. The development of this disorder is influenced by the combination of genetic and environmental factors. It is crucial to emphasize that ASD is not an illness or disease. Rather, it is a neurological condition that impacts a child's ability to concentrate, think, learn, focus, and solve the problems. Additionally, children with ASD often encounter the difficulties in expressing themselves through facial expressions or gestures. The primary objective of this project is to investigate and assess various machine learning algorithms utilized by different researchers for the detection of autism spectrum disorder. The study aimed to compare the accuracy and efficiency of these algorithms and critically evaluate the machine learning classifier employed in ASD diagnosis. The ultimate aim is to develop a system that streamlines the diagnosis process, reducing both the time required for detection and the number of features necessary for the precise identification. Moreover, the project acknowledges the limitations of the previous studies, recognizing the areas that should be improved and proposes the future research direction. Through a thorough analysis of existing methodologies and the proposal of the potential enhancement. These are the basic requirements that are needed to build this project. The software requirement: Python IDEL with version of 3.7 or Anaconda with version of 3.7 or Jupyter or Google Colab. Hardware requirements: operating system as Windows or Linux, processor of minimum Intel i3, RAM of minimum 4 GB, hard disk of minimum 250 GB. And this is the flow of the project. The first one is importing the libraries. In this step, the necessary Python libraries are imported. They are Pandas, used for the data manipulation, NumPy, support for the mathematical operations, and sklearn, that is used for the mission library that includes tools for data processing, model building, and evaluation. TensorFlows and Keras for the libraries building the training the neural network, particularly the CNN and the multi-layer perceptron. And then the Flask, a web application framework used to create a web server that receives user input and return the prediction. And the second one is exploring the dataset. In this stage, the dataset containing the information that are relevant to the autism spectrum disorder is carefully examined and analyzed. Exploratory data analysis techniques are applied to gain insight into the dataset structure, distribution, and potential pattern. And the third one is data pre-processing. The data processing involves preparing the raw dataset for using a machine learning model, combining a data processing step of handling the missing values, encoding the categorical values by converting the non-numeric data into the numeric format, and feature scaling, that is of ensuring the numerical features have similar scale to avoid the bias in certain algorithm. And then fourth one is splitting the data to the train and test. The data set is divided into the two separate tests, the training set and the testing set. The training set is used to train the machine learning model, while the testing set is used to evaluate the performance. This step is essential to measure how well the model generalizes to unseen data. And the fifth one is building the model. In this step, several machine learning models are constructed to predict the presence or absence of ASD. The first one is SPM. It is a powerful supervised machine learning algorithm used for classification and regression tasks. In the context of classification, such as ASD detection, it aims to find the best hyperplane that can separate the data points belonging to the different classes. In a binary classification setting, the hyperplane creates a decision boundary between the positive and negative instances. The support vector or the data point closest to the decision boundary and are crucial for defining the margin. And the second one is naive-Bayes. Naive-Bayes is a simple and fast probabilistic classifier based on the Bayes theorem. In the context of ASD detection, naive-Bayes assumes that all features are conditionally independent given the class label. This is known as naive assumption, as it not hold true in all the classes. However, even with this simplifying assumption, naive-Bayes provide accurate prediction, especially when there are large number of features. And the third one is logistic regression. It is a popular linear classification algorithm used for binary classification tasks. And here, despite its name, it primarily used for classification rather than regression. It models the relationship between the input features and the probability of the binary outcome as of ASD or non-ASD. And the fourth one is KNN. KNN stands for K nearest neighbor, is a non-parametric and lazy learning algorithm used for classification and the regression task. In the context of ASD detection, KNN would classify an individual based on the majority class of its K nearest neighbor from the training data set, and the KNN is simple to understand and implement, but its performance leads to the sensitive to choice of K in the distance metric used to determine the proximity. And the fifth one is multi-layer perceptron, as MLP is a type of feed-forward artificial neural network contains of multiple layers which are interconnected by the neurons, where each neuron is simple computational unit that processes its input and passes the result to the next layer. The first layer is of the input layer and continued with the hidden layers to the output layers. In the context of ASD detection, an MLP lead to take the input features related to the individual and pass them through the layers of neurons to produce a probability or binary classification as of output, which leads to the ASD or not, which are highly versatile and can learn the complex patterns from the data, making them suitable for the wide range of tasks. And the sixth one is CNN, stands for Convolutional Neural Network, specialized type of neural network effective for image-based tasks due to its ability to automatically learn the spatial hierarchy of the features. In the context of image-based of the pooling layers and multiple layers, including to the fully connected layers that will create an spatial hierarchy of the features. In the context of ASD detection, a CNN would use its convolutional layer to detect the various patterns and the edges in the input of the test. These layers learn features that are useful for the classification task. And the next step is training the model. In this, the model built and the previous step are trained using the training dataset. During the training process, the model learns the patterns and relationship between the input features and the target variable as of ASD diagnosis in this project. And the seventh step is user gives the input. A user interacts with the system by providing the input data in the form of Flask web interface, and this relevant features related to the individual being assessed for the ASD. And then the eighth step is the given input is pre-processed for prediction. The given user input is pre-processed to ensure it aligns with the data format used during the model training. It involves applying the same data, the processing steps as used for the training data set. And the ninth one is trained model is used for prediction. The pre-processed user input is then fed into the training machine learning model. Each model makes a prediction regarding to the likelihood of the ASD based on the given input. And the last one is final outcome is displayed. The prediction made by all models are combined and the final outcome is displayed to the user. The user will receive the information about the likelihood of the individual having the ASD based on the collective decisions of the various models. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder containing of the different files within it. The first one is of dataset folder containing of the dataset, and the static folder containing of the CSS file, JS file, images, and the bootstrap files within it. And the template file folder containing of different HTML documents like of home, index, result, sign in and sign up. And the app is an py file where it likely contains the information related to the front-end logic. It includes the code written in Python that handle the server-side operation such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the IPYNB is a data Jupyter notebook which contains the combination of the code, graph, output all in one place. It allows the user to write and execute the code in the individual cell. And the signup is an database file which contains of the database used to store the user information. To execute the project, first we need to copy this address of the code folder and open the Anaconda prompt. Here, first we need to change the path of the Anaconda prompt to F because our code folder is present in F. That's why I'm writing this command and the path is changed, and here we need to write the another command as cd space paste the address of the code folder and click on enter button. After this we need to write another command, that is python space app.py. By this command is used to execute the Python script and perform the runtime check for any syntax errors or the logical issues. And then click on enter button. After running this app.py file, the Flash framework will host the application locally at the default address as of like this. And we need to copy this local link provided by the framework and paste it on any web browser. And I prefer to use the Chrome. And opening this Chrome and pasting this and click on enter button. By this we redirected to the home page contains of the title of the project sign up button too, and click on sign up button, and here it redirected to the registration page contains the information and the necessary details need to be provided to create the account. But our account is already created, that's why I'm using the sign in button. Here we need to enter the username and password, as of mine as admin, and click on sign in button. Here we redirected to this page, and here we need to enter all these columns as A1 score is 0 or 1. A2 score is 0 or 1, A3 score 0 or 1. We need to enter as our, I am entering A7 as 0, A8 as 1, A9 as 1, A10 as 1, and result as 8. And click on submit button to get whether the person is having the ASD or not. After submitting, it redirected to the result page and classified as ASD. And this way, we can analyze and detect the autism spectrum disorder using the machine learning technique. In conclusion, this project highlights that autism spectrum disorder is a multifaceted developmental disability that necessitates early identification. The existing screening tools for detecting the ASD are both time-consuming and expensive. However, the utilization of machine learning technique, including the SVM, random forest, decision tree, and many more, are giving the promised outcomes in the diagnosis of ASD. The project proposes that leveraging the machine learning can lead to the development of the system that streamlines the diagnostic process, reducing both the time required for the diagnosis and the number of features needed. It underscores the significance of early identification and intervention for the individuals with the ISD, emphasizing the potential of the machine learning in facilitating the timely diagnosis and treatment.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.